Let's jump right into the ultimate blueprint for mastering the Eco-Egypt Utility Scale PV Training Program. Now it's time for the task list for Level 01. If you're an engineering student or a pro ready to leap from basic theory to executing real-world utility-grade solar projects, you're in the right place. Today, we're mapping out the exact tasks, the engineering deliverables, and the rigorous assessment standards you need to report on and absolutely master. Let's do this. Okay, here's our course syllabus. We'll kick things off with a welcome to Level 1, move right into Chapter 3 project types, hit the engineering deliverable list, look at core software design tools, and finally, prep for the final interview assessment.
Section 1. Welcome to Level 1, the foundation of PV training.
So, the entire philosophy of the Eco-Egypt program is built on one totally non-negotiable standard, and that is integrating a 100% design methodology with hands-on application. You don't just sit back and observe here, you execute. This program really empowers engineers worldwide to step directly onto a site or, into a fast-paced design firm and coordinate the whole shebang, from module layout all the way to grid connection.
Now, you might be wondering, what exactly does Level 1 entail? Covering Chapters 1 through 3, it introduces solar PV fundamentals, the core components, and, this is key, it gives you full design capability for commercial and industrial or C&I systems. We're talking about integrating battery energy storage systems, or BS, and those really complex solar pumping solutions required for robust, commercial-grade energy demands. It's serious stuff.
Section 2, Chapter 3, Project Types, the Framework.
All right, it's time to report about what you studied and really break down those core design packages. Chapter 3 focuses heavily on design for residential and C&I. Basically, this bridges that crucial gap, taking you from standard residential setups right into the highly demanding world of commercial and industrial design, where, let's face it, the math gets harder and the stakes get a whole lot higher.
So, the crucial point here is understanding the execution. You're required to apply comprehensive sizing methodologies. We're talking about creating the 4 design packages for the 4 project types of Chapter 3: battery energy storage systems, solar pumping solutions, grid-tied systems, and PV diesel hybrid systems. You literally have to prove you can size a system for every single one of these. No skipping.
Section 3. The engineering deliverable list, the execution.
It's not enough to just know how a system works in your head. You must report about what you studied on paper. Your base design engineering deliverable list, the EDL, is essentially the package issued for construction. You've got to produce drawings, calculations like your BES sizing, simulations via PVsyst, comprehensive equipment data sheets, and formal reports that include your design basis. And listen, missing even one category, that means your design is incomplete.
Section 4. Core Software Design Tools, Building the Report.
Okay, so the program operates on this 3 tools, 3 deliverables concept. It's like a giant puzzle. Step 1 is SketchUp, where you'll build a 3D PV array layout and conduct an absolutely crucial shading study. Step 2 is PVsyst, which is this powerhouse tool used to generate full simulation reports, yield projections, and loss diagrams. And finally, Step 3 is AutoCAD, where you'll draft your highly detailed PV layout drawings and your AC and DC single-line diagrams. 3 tools, 3 precise outputs.
And this brilliantly illustrates the level of detail we're actually talking about here. You'll draft highly structured PV array layouts and complex AC single-line diagrams showing inverter connections, circuit breakers, and transformers. Guys, this isn't some messy whiteboard sketch. This is the real, kind of intimidating AutoCAD output you are expected to produce. And, well, hopefully without crashing your computer in the process.
Now, your specific goal in SketchUp is to produce a 3D model of your PV array sitting right on a real satellite site image. But it's not just to make it look pretty, right? You have to calculate the exact inner row spacing and validate shadow-free operation at the winter solstice. By capturing shadow screenshots at 9 a.m., 12 p.m., and 3 p.m. on December 21st, you prove your layout actually works when the sun is at its absolute lowest point.
Section 5. The Final Interview Assessment. The Assessment.
70. Let that sink in. That number is your ultimate target. To pass Level 1, you must achieve an overall mark of 70 out of 100. The assessment features 5 technical sections, and they're each worth 20 marks. To even be considered for passing the whole thing, you have to score at least 14 out of 20 on every single section. The solar industry demands precision, and for sure, so does this test. Let's break down the logistics of that interview room, because you need to know what you're walking into.
You'll face 15 questions in total across those 5 technical sections. You only have 60 minutes, but here is the real kicker. There is no multiple choice here. None. All answers will be discussed verbally with the assessor, and you are totally required to show clear engineering reasoning. You can't just blurt out a number. You have to explain the why behind your entire design.
Now, what's really interesting here is that you need to be prepared for the specific interview questions for each chapter. For chapters 2 and 3, you're going to be grilled verbally on PV component and design factors. Expect questions on temperature coefficients, system losses, AC-DC ratio, and precise string sizing. Honestly, if you can't verbally explain how a temperature coefficient impacts your open circuit voltage on a freezing morning, you simply won't pass.
So, here we are. You have the syllabus, you know the 4 core design packages, and you understand the rigorous standard of the verbal assessment. The blueprint is literally right in front of you. But, knowing the path and actually walking it are 2 very different things. When you sit in that interview chair with 60 minutes ticking down on the clock, will your design logic hold up under the pressure? Or will your grid collapse? It's time to find out.